Hello. Hello. Okay. ठीक है. Hi, so today we are grinding DSA questions. Leetcode DSA questions. Grinding Leetcode DSA questions. Okay. So okay. So I'm solving this one. Search in rotated sorted array. Right question. Okay. So there is an integer array nums sorted in ascending order with distinct values. Okay. Array which is possibly rotated at an unknown pivot index. So whatever the array we had, it is rotated at some pivot index. So it is saying suppose the pivot index is uh, 3. So basically it's 0, 1, 2, 3. Um, okay, 0, 1, 2, 3. So it is rotated, which means what will rotation mean? That all of the next elements are showing up here after rotation. It looks something like after rotation. It looks something like 4, 5, 6, 7, 0, 1, 2. Okay, 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 okay. 0, 1, 2, 4, 5, 6, 7. And after rotation, 23 to see. Okay. So given the array nums after the possible rotation as an integer target, okay, return the index of target if it is in nums or -1 if it is not in nums. Okay, I just have to figure out if this particular target is present in this given array. If it is present, I have to return the index, otherwise just -1. And algorithm runtime complexity, expected complexity is O of log n. Okay, okay. So, okay. Um, Target for the first question is 0. Okay, and it is basically the array is sorted, but it is rotated as well. So we have to see. Hmm. Uh, Basically, if you see, if some array is sorted and then rotated at a particular pivot, it forms something like a mountain array. I think, yeah, that's what it is called. So basically, the elements they keep on increasing up to a point, and then after that they'll just decrease. So it's like from 4 we go to 5, from 5 we go to 6, from 6 we go to 7, and then from 7 we just go down to 0, and then again it may increase. Okay, so it's easy to figure out this index, but what we have to actually figure out is the presence, is where is the target present. Hmm. Target is equal to 3. Okay, it is not present. Actually, the complexity which they are expecting, -1. That is little. Okay, O of log n. O of log n. O of log n. O of log n. This tends towards binary search or something. Mm, it's binary search. Yeah. Okay. Uh, uh, how can we apply binary search over here? We have a target 0, and I need to figure out whether 0 is present. Okay. So binary search can be applied on a sorted array. If I sort it with view of n and then complexity, which we do not want. Okay. So what are we looking at? What are the different ways of doing it? Um, if I find out this index where the starting element is present, it is at 4. So I have to apply binary search. Um, so if it is a regular sorted array, what do we need? We need a low, high, uh, basically, yeah, we have two indices, we get one mid, and we try to figure out whether the target lies towards the left or towards the right. Okay. Mm, okay. 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 So the array is rotated, but even after that, a small segment of it would be sorted. Basically, two small segments of it would be sorted. So what if I apply binary search on those two parts separately? So what I mean is, um, I have the array, so I'll try to figure out the the index up to which my array is sorted. So let's call that k. Let's have this. Okay, now I'm iterating from 0 to n. 0 to n minus 1, and what I am looking at is if nums of I is less than uh, nums of I minus 1. So let's start with 1 and go to n. So if at any point it is less than, what if it is equal? 4, 5, 6, 7, 0, 1, 2. So nums of I here is less than nums of I minus 1. Yes. So this is the index. K is equal to I. So in our scenario, K is equal to 0, 1, 2, 3, 4. 4. Okay. So once I have this equal to 4, what I know is that array is sorted from 0 to k minus 1 and k to n minus 1. This is what I'm aware of. What if they were equal? If it was 7, 7, then this would be the answer, right? So if it is less than, only then we will take the index. This is fine. Yeah, yeah, okay. Uh, so I can apply binary search. So I can take low as 0 and high as k minus 1. So while low is less than equal to high, k into mid equal to low plus I by 2. Now if nums of, sorry, if, okay, yeah, if nums of mid is equal to target, then we can return mid. Else if nums of mid is greater than target. So suppose we are looking at 4, 5, 6, 7. The like this is 0, k is 3, 3 plus 3 by 2, 1. So 0, 1, 5, and one subnet, and target is 0, or let's say target is 6. Sorry, target is something less than it. So target is 4. Now subnet is 5. It is better. So we have to move towards the left hand side, which means that low will stay the same. I will change to minus 1. Else low will stay the else low will change. I will stay the same. Low will move to mid plus 1. So one scenario is this. Another scenario would be the second half, where so we can take low as k, high is a minus 1, and then we do this. Okay, and again I think the same logic should work. And yeah, if after all of that I'm unable to find another, maybe I can return minus 1. Let's see. Okay, unless out of bounds exception for length 1, 937, right? For length 1, so 1, that's okay. Since it is of length 1, then 1 minus 1 will be 0. Mhm. I can add a check either here or before the several, but let me just add the check here. If mid is, or maybe add a check. Basically, both low and high should be within the range. And mid 181 or 196 is passed. 1 and 1. It is the issue. If we have just a single length array, 1, target is 1. So I start from 1, n is 1, so I don't go anywhere. So my k is okay, so k stays at minus 1. Okay, okay, okay. So I think if, wait, if you have two elements, then k would be changing. But if k stays at minus 1, we can assume that our array is sorted. If k is equal to minus 1, array is sorted in whatever scenario. Okay, if array is sorted, we can have just one loop which will be this, and we can increase this to particular high would be n minus 1. That is it. Use the test case. Oh, nums is 1, target is 1, output minus 1, expected is 0. Let me check once. So since n is 1, we would stay at k equal to minus 1. If k is at minus 1, low is 0, high would be also 0, low is less than equal to high, yes. So check mid, so 0 plus equal to 0. So is mid greater than, array, mid can be greater than equal to 0, right? See, it is not clean code, but first I'm trying to figure out if the logic is correct, and then we can update the, we can make the code modular. Let's see, accepted. Yeah. So solution is correct. Now, see, we are repeating the same logic twice, the mid logic, right? So good way is obviously to create another array, sorry, another function, which would be a helper function. Here it is performing binary search, so I'll just name the function binary search. We need low, we need high, we need target, and we need nums as well. Okay, and now let me copy this entire thing. Okay, oh, up there. Sorry, my window crashed. Am I still live? Yeah, okay. So we have low, high. What did I do here? Uh, I think I was copying. Yeah, yeah. Okay. So let's just copy this part. Let's just add this part over here. Now I'll receive the low and high. Okay. So let it be. Low should be less than equal to high. It is this, this is this, this is this. We're returning. Otherwise, they will return minus one. Wait a second. Am I sharing window capture? So it should be yeah. Let me check once if streaming is happening or not. Yeah, okay. Okay, okay, okay. So this is done. This is done. Now this is what I can simply do is rather than doing all of it, I'll simply call binary search on. I'll call binary search. We get some value. We are returning. Don't get anything. We are returning minus one. Okay. So return binary search of low high target nums. Low high target and nums. This part. Here I can also here also I can just call return binary search. Actually, I'll have to basically I have to take care of all the binary search results. Result of this binary search of low, high, target, randoms, and I check binary search, low, high, target, nums. Okay, and I have to take care if either of them is not equal to -1, if or basically if A equal to -1 and B equal to -1, we'll have to return -1. Otherwise, we have to return uh, whichever one is not equal to -1. So return uh, A equal to -1, then you have to return A, sorry B, otherwise B. Let's check. Okay, yeah. So this is fine. I think this is O of log n solution because we are doing binary search only. We are not doing anything else. Okay, what is this? Uh, Wait, since we have this loop, its time complexity would be called as O of log n. Let me check. Hmm, what is PC and SC? Let us also go through some solutions shared by the Leetcode community so that we can get a better idea if we can improve the solution in any way. So let's just see some Java solutions. Find a sorted pair in ascending order. Hmm, number, okay, so since we are doing the two things using infinitely sorted, ascending order, I think it is sorted. Middle numbers equal to target, stars, numbers equal to sorted. Between them, all numbers are sorted in ascending order. Between all the numbers, that means the original array is also sorted in ascending order. So that means in order including. Yeah, correct. This is correct. Of course, all numbers are sorted in ascending order between M and R. This is also correct. Uh, because numbers between N and R are sorted, between number and numbers are not sorted because 0 is coming after 7. Okay. In this case, it's true. So we are sure all numbers are sorted between L and N. Next typical one is search process to move L or R depending on the target. In this case, if nums of L is less than equal to target, less than equal to nums of N are true, we are sure that target is involved in because all numbers are sorted. Okay, they are doing it via one binary search only. Okay. Oh, instead of just N. Yeah, so our solution will be of N logarithmic time complexity because of this rule. of n plus log n. Hmm. So what we can do is, what they have done is, this is a good approach actually. Left is equal to 0, right is equal to minus dot length minus 1, while left is less than equal to right. They are calculating mid. If mid is equal to target, it's good. Otherwise, we are just checking if the entire part is sorted. If nums of mid is greater than equal to nums of left, which means that that part is sorted, right? This means that the left part is sorted. And if the left part is sorted, nums of left, then what they are doing is less than equal to target, and target is less than, and the target lies between this thing, then they are simply moving the right and left there. Otherwise, if it's not sorted, nums of mid is greater than equal to nums of left. If the number lies in the second part, one of the parts need to be sorted, right? Both of the parts cannot be unsorted. So one of the parts will be sorted. And yeah, so this is a good solution. Let's try that. So see, this is the benefit of going for solutions. We'll find some better solution and some better implementation for this. Okay, so maintain minimum stop length. Uh, Low would be 0, high would be n minus 1. So we'll just iterate low to high. Mid would be low plus high by 2. If target is equal to nums of mid, well and good, let's just return mid. Else, if we're trying to check if the left part is sorted or not, the left part will be sorted if nums of mid is greater than or equal to nums of mid. Else, yes. Now, if the left part is sorted, we try to find our target in there. So we just try to find if our target is greater than equal to nums of low, and if our target is less than equal to nums of mid. If this is the scenario, we know that our target lies in the left search part. So let's just adjust our high, sorry, our mid, our high, yeah, high should be mid minus 1, because it would be in that part. Otherwise, if it does not lie in that part, mm, if it does not lie within that part, if target is then we can move to the right hand side. Correct? Yeah, I think. Else, what happens? Else, we are trying to move to the right side, and we are trying to see is our target lies in that part. Our target is greater than equal to and less than equal to terms of height. So it would be in that right search part. If this is the condition, it is in that part. We can move our low to mid plus 1. Else, we have to move our high to mid minus 1. Let's just do all of that, and after that, let's just return minus 1. I hope yeah, okay. So this is a good solution. ठीक है. So let's just note it down. Search, search in rotated sorted array. binary search, medium difficulty. So this can be solved in O of log n of n need to perform regular BS while also tracking. Yeah, I can perform regular BS. Yeah, okay. So we're done with this question. Let's move on to the next question. So this is done. 1 second smallest element in a string. Let's pick the next question. Which question should we pick? Second smallest element in a string. We don't have any question. Yet largest element in a string. What else? Minimum path sum. Minimum path sum. Okay. In kth largest string, kth largest element, you are part of a university and need to keep track of the kth highest test score from applicants in real time. This helps to determine the difficulty for which a given integer k contains a stream of test scores and continuously returns the kth highest test score. Kth highest test score. K is another name for the kth highest score in the sorted list of all scores. Kth large initialize object with the integer and the stream of test scores nums, adds a value to the stream and returns the element representing the kth largest element. Okay. So I believe we need priority queue to solve this one. Let's see how we can implement. So for kth largest, yes, we can take a priority queue and we need the kth largest value. So kth largest means, so suppose I have 1, 2, 3. These numbers I have 1, 2, 3, 4, and k is 2. Kth largest would mean second largest. So largest would be 4 and second largest would be 3. Okay. So I need the kth largest decimal means. Okay. So what I can do is if I have a priority queue, okay, and since I am only concerned with top k elements, I'll keep I'll try to keep my priority queue within this size of k, which means if I have just two elements, suppose I add one and then I add two. Now when I have to add three, I'll add three, and then I have to add four, I'll add four. So I'll maintain k elements on my priority queue, and second largest would mean p. So which means it should be a min heap. Correct, because in min heap 3 would be at the top. So yeah, I have to use many priority queue of size k. So that will help me keep track of top k largest elements. Yeah, okay. Now, if we try to implement it, obviously I need the priority queue. So let me just instead create one priority queue integer. What should we call it? Let's call it heap, or let's call it in heap. And other than that, yeah, we also have to maintain the heap. Then this dot k would be k. Now I have to add the nums to my priority queue. Okay. So first, let me just instantiate it. Okay, priority queue. And then what I'll do is I'll iterate to nums, and I'll have to add. So we have a separate function for add. So we'll just call the add for num. Now in here, where I add the number, adds a new test score to the stream and returns the element representing the kth largest element in the pool of test scores so far. Adds a new test score value to the stream. Okay, okay. So what we can do is we can add the element to the min heap, and we can check if min heap dot size is greater than k. We can remove the item. That's it. We are not making any loop because at a particular time we are only dealing with one of the numbers, right? So if I'm adding one number only, there is only one, like it might increase by just one size. So I'll just hold it and it would be removed. And what I have to do is I have to return when heap dot heap. Okay, this is a easy question, but we will still go through the discussion section to figure out if there is something more for us to understand. I should mention this number also. Okay, okay. So now, let me just go to the section, solution section to figure out if there is something for us to understand. Hmm. So here what they are doing, this is a better approach actually. Here what they are doing is they are, solving this. They have written the same code basically twice, here as well and there as well. For an unknown signaling the size is less than k, it is starting if it is otherwise you remove and then you add. Yeah, it's pretty much the same stuff. So yeah, we are good with kth largest element in a string. Let me note this also. Now we are at minimum path sum. This is one of my favorite questions. I've solved it many times before, I think. I can see. Yeah, see, I solved it on 2025. Okay. So let me again solve it. minimum path sum. Now solving 64 minimum path sum. Okay, how to solve it? So given an m cross n grid filled with non-negative numbers, find the path from top left to bottom right. Actually, I was asked this question on my in my Google interview. I think in 2022. Yes, I was asked this question in my Google interview in 2022, and I was unable to answer that. Anyways, now I would be able to solve it. So we have been given a grid, and we have to figure out a path from top left to bottom right. Okay, so 1 3 1 1 5 1 4 2 1. Top left to bottom right. Okay, uh, which minimizes. Okay, we have to minimize the sum of all numbers along the path. Minimize. This is the keyword. What we have to do? We have to minimize, or we have to maximize, or we have to count, whatever. Okay. So here we have to minimize, and at any point I can only move either right or down. Okay. So, so what I would do. So basically this question is screaming of dynamic programming. So obviously it is dynamic programming. So I will add. So I'll have two indices. One is the row where I am present. Another is the column. Row column would give me an idea of where I am currently. That uh, we'll have an M and we'll have an N. So basically, I'll start from f of 0, 0. Correct? We will start from this part, and we can move to either move down or we can move right. So I have two options. Like basically, if this is f of 0, 0, from f of 0, 0, I have two options. Uh, I can either go to right, which would be f of r plus 1. Sorry, right would be in r c plus 1 m n grid. Or I can either go to bottom, which would be, or let's call it down, which would be f of r plus 1. Column will stay the same, and this. Okay. So if I am at f0, 0, I can either go to f of 0, 1, or I can go to f of 1, 0. Now I'll have to simulate all the possible paths and all the possible, uh, this maths summation. So see, whether I go right or go down, I am at in the 0, 0. So this value we have to count, correct? Which means what this f function would have this summation, would have the value presented RC. So we do grid of RC. Okay. Plus now we have to minimize. So we will minimize from right comma down. Okay. We will try run also. Let's see first. So yeah. Now the base conditions. So base conditions are always easy to figure out from this thing. Okay. C plus one is this. One thing we can do is let's try run the code so that we have a better idea. Yeah. Okay. So let me copy this thing. Let me copy this. Okay, so this is 0. Sorry, this is 0. Sorry, why is it so slow? This is 0. This is 0. This is 0. This is 1. This is 1. This is 2. And this is 2. So what I'm saying is we will start at 0, 0. Uh, I don't know, it is very slow, so I'll just type things. So we start at f of 0, 0. Okay, now what we are doing here is we are saying either we move right or we move down. So either we move right, so uh, right would basically mean 0, comma 1, or we move down. So down would basically mean 1, comma 0, right? Now again, from here, I have two options. From f of 0, 1, I have two options. I can either move right or I can move down. If I move right, I'll go to 0, 2. If I move down, I'll go to 1, comma 1. Okay, this is for this. Now again from f of 0 to, I have two options. One is right, but if you see, if I go right, let me write it down. If I go right from here, I will do this. So I am exceeding my limits. Okay, I have moved out of my matrix. So this is a this case is this is an invalid case. Okay, so I need to handle this scenario in my code. Okay, so this is how we can figure out the edge case. Okay, other than that, from f of 0 to, I can either go right or I can go down. So when I go down, I would go to 0 to, so 1, comma 2. Again from 1, comma 2, I have two options. One is f of uh, 1, comma 3, which is right, which is again an invalid invalid case. And another would be f of 1, comma sorry, f of 2, comma 2, which is the desired state, the desired index. Okay, so here also we need to add some condition. This is also this is our base condition. Okay, so this is our base condition. Okay, now let's look at this first. So f of 0, 3. This is basically, this means that this path is returning in no value, in no result. Okay, let's remove that. For f of 1, 3, what for f of 2, 2? Okay, what would be returned? So f of 2, 2 would basically mean that we are starting at, suppose if I look at it in terms of the function f, then f of ij is telling me the minimum cost to go from f of ij to the rightmost bottommost cell, right? Correct. So for f of 2, 2, this simply would be 1. Wait, f of 2, 2, this would be 1. Okay, so f of 2, 2 is sorry, f of 2, 2 is 1. Okay, so this will return 1 if we check here code. So this thing is returning 1. Now f of 1, 3, f of 1, 3, it is an invalid case. So let me just mark it as invalid case. This is one invalid case. Okay, so this is returning 1. This is invalid. So for invalid, if you return max, if you return int of max, then see, it will not hamper our result because we are saying math dot min, right? So it would not hamper our result. So we can do that. We can return int of max for the invalid cases. So let's just add that if r is less than 0 or r is greater than equal to n or c is less than 0 or c is greater than equal to n, we should return integer dot max value. Okay. Other than that, I have to check if r is equal to n minus 1 and 20. Yeah, and c is equal to n minus 1. I can return grid of rc. Okay. Here, what we are doing is, and n is grid dot length, and n is grid of 0 dot length. Okay, and we call the function f, so we return f 0 comma 0 m comma n comma grid. Yeah, so it's working. If you want, you can try run through the entire thing. Basically, we will return int max from this part and this. So the min of this will be stored here along with the summation of f of 1 plus f of 1 comma 2. So 1 comma 2 is 1, so 1 plus 1 2. So this will return 2. Again, we will take the min of these two, which means we will take 2 to here along with the summation of 0 comma 2. 0 comma 2 is 1, which is 3. So yeah, you can simulate it, but we can see the result here. So now let's memoize this stuff because obviously we are doing some repeated calculations. So to memoize, I'll need a 2D DP. So let's prepare a 2D DP with a new int m n. I'll have to pass the DP. I'll have to pass the DP. Pass the DP. Take the DP. Here. Okay. Now here I'll add. Okay. So want the DP to be filled with -1. So y equal to 0, I less than m, I plus plus arrays dot fill dp of I with -1. Okay, so now here, yeah, here we'll add a condition if dp of rc is not equal to -1. It means we have calculated the value for this dp of rc. So let's just return that value. Yeah, return the dp of rc value. Otherwise, here it will be dp of rc. Yeah, so passed, and we pass this other after this this is so basically we initially did recursion, then we have memoized it as well. So another approach is tabulation. So we can tabulate the we can also tabulate this. Basically we can avoid using this entire recursion thing, the stack space thing, and we can have this working on a DP on a tabular approach in itself here itself. So how will that work? Let's see. So we are starting. So in recursion we are moving from 0 to n minus 1, 0 to n minus 1. So here I'll start at n minus 1 and I'll do this. Here I'll start at n minus 1 and I'll do this. Okay, and we will return 0 0. Okay, and we check. We can pretty much use this same logic. Okay, so let's just copy paste. So write basically means dp of sorry dp of r c plus 1. This would mean dt of r plus 1 c. This is, yeah, okay. Let's take r c. Now, one thing is that for n minus 1, the plus 1 will not matter, and for minus 1, this plus 1 is not valid. So, one thing which I can add is I can add this check here itself. We can add the check. Here, if r is equal to m minus 1, then we can take down as integer dot max value. If uh, c is equal to n minus 1, we can take it as integer dot max value. We probably don't think this. We can have this. Yeah. Okay. Uh, integer dot max value if c is equal to n minus 1. That is wrong. Roads, they are going from 0 to n minus 1. I think the base is, I think, yes. Mm, Actually, this is wrong. We can start from n minus 2 and n minus 2 for, but we have to populate the values beforehand. So, uh, yeah, we have to populate the value. So, suppose if I talk about the last row, n minus, if I talk about the last row, the column would vary from 0 to uh, n, right? So for the last row, which is m minus 1 and c, let's do wait. So basically, when they are at the last row, if they are at 4, we have to move to 2. So we will have to sum this up, right? So for 4, it would be 4 only. For 2, it would be 4 plus 2, 6 plus 1, 7. So this is from top. So this is top down. Tabular approach. This is the tabular approach. Uh, I think it cannot be space optimized further because we are dependent on both the previous as well as like previous row as well as the previous column. Or you can say yeah. Yeah, yeah, yeah. Yeah, okay, so this is done. It is a simple problem. So I can note it down here. Minimum path sum. Okay, so that is done. This is done. Let me mark it. Length of the longest subsequence such that XOR of adjacent elements is equal to k. Where can we practice it? Okay, we'll check that later. The code is hmm. Decode this. You have intercepted a secret message encoded resisting numbers and known by the following nothing. One is B, one is A, two is B, okay, 25 is right, and 6 is E, okay. However, by encoding and decoding the message, you realize that there are many different ways you can decode the message because some codes are contained in other codes. Uh, 2 and 5 versus 25. Okay, so for example, 1106 can be decoded into AAJF with a grouping 11 times 6 or KJF with a grouping 11 times 6. The grouping is invalid because 0 is not a valid code and this is invalid. Given a string S containing only digits, return the number of ways to decode it. Therefore, the message decoded. I have to find out the number of ways to decode it. If the string cannot be decoded in any valid way, return 0. Okay, okay. Number of ways to decode. So if you have 2 to 6, you can have 2. You can also have 22. You can have 2. Basically, if you have 2 to 6, you can have 2 or 22. Sorry, basically, division, I have to figure out. Division can be like 2 to 6 or 2 to 26 or 22 axis. Yeah, this is how we can have the divisions. Okay. Hmm. Something we devoted as okay. So at if we start from 2, I have two choices. I can either decode 2 or 22. Basically, yeah, those are the only two choices I have. Those are the only two choices I have. Okay, so let me open this further. I have two choices. Yeah, yeah. Decode this or basically uh, so I have two choices. Choice one is decode 2 choice 2 is decode 2. Now choice 1 decode 2, or I can have a choice to decode a number only if it is not 0. Should not be 0. And if I decode 22, or basically this actually means decode one letter or digit, or decode two letter or digits. Now if I decode 2, then it should be between 10 and 26. So you cannot have 32. Okay, so this is what I have to keep in mind. So I have two choices at any particular index. So this is DT. I think this is DT only, because we have some limited number of choices and we have to exhaust all the choices to figure out the solution. So 26 and single choice. So if I start from index 0, or f of 0. Okay, I have two options. I either move to basically I either decode 2 and move to the index 1. Okay, or I decode 22 and I move to 0, 1, 2, the index 2. This is These are the two choices I have. Now when I am at f1, I have again, see it. Let me just write it down. Yeah. So now when I am at f of 1, I again have two choices. F of 1, I either decode 2, which means I'll get 2, plus I can decode either 2, or I can uh, one is decode 2 and move to the next index. Another option is to decode 26, because 26 is also valid, and move to index 3. Now index 3 is an invalid index, so yeah, we will have to add those checks. For now, let's see what is happening. What do we have to return here? We have to return the number of ways to decode it. Okay. So if you have to calculate it's the number of ways, then we just have to return. We don't have to add this to, basically we just have to return the number of ways, right? I think we can simply code it up here. Private int helper. Okay, so I'll have an index and I'll have the string. Let's also think that we have the string length. So if I am trying to decode one letter, then it should not be 0. That's the only criteria. So int choices. Now if end sorry I'm trying to decode one letter or digit. Okay. If s dot char at index not equal to 0, I have this choice of decoding 1, so I can do choices plus equal to 1, and I can also calculate choices plus equal to 8. Choices plus equal to helper of index plus 1 and s. Yeah. Another thing is, if I can decode two letters, so I have to see that int parent as would be uh, 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 this will not be int, right? This will be char, and I can do string builder is equal to new string builder. Now what I have to give it give to it is, so what I can do is current to chars dot append s dot char at index and s dot char at index plus one. Okay, so I'll get some two digits or two letters, and I'll try to convert into integer. So chars value is current to chars. Can I convert into integer? Yeah, integer dot parse. I thought we don't have this thing. Yeah. So this is this. Now if chars value is less than equal to 26 and chars value is greater than equal to 10, only in that scenario equals to m s and will return choices. And we need to take care of the base conditions. Base conditions is when if basically if index is greater than equal to n, simply return 0. That's it. Helpful. 0, comma, int n is s dot length 0, comma 10, comma s. Here also we have to ensure that another thing which we have to ensure is if index plus 1 is less than 10, only then I should be proceeding with the further calculations. If it is 10, string builder का नाम तो string I'm rolling 0. Why? Why? अच्छा, wait. Oh, oh. I'll also have to increment the count. I'm not incrementing the count anywhere. Choices is equal to 1 plus. I have one choice here. Here again. Choices is equal to 1 plus alpha. That, that's, that is what we had to do. Okay, what is the issue? Let me copy my code and paste it here. My code is this. Let me change it to this. Vector line. Yeah. Let me just try run the entire stuff. So we have helper. Yeah, index is whatever equal to and 2 to 6 we are let's try run 1 2, it will be shorter. So 1 2 and here 0 0 1. Okay, if index is greater than equal to n, return 0. It is not, choices is 0. Is that char at current index is 0. So character at it is not equal to 0. No. So its character is not equal to, it's not char at, this would be this. Yeah, it's not equal to 0. Then we can move inside and we are saying price is equal to 1 plus helper of. So f of 0 was called. So here we are doing 1 plus f of 1. Okay, that's what we are calling. Let's just remove these parts. Now 1 plus f of 1. So we again go inside and we are saying index is 1. Index is greater than equal to n, then it is not, choice is 0. If s dot caret index is not equal to 0, we have another choice of 1 plus alpha. So again, we are having a choice here which is 1 plus f of 2. So again, we call f of 2. Here n is equal to 2, so it is greater than equal to 2. So this will return 0. So this will return 0. Let me write it in red. F of 2 will return 0. So this will return 1. So this will return 1. Sorry, 1. So this entire stuff will return 2. This is 1 plus 1, 2. So here we are returning 2. Okay. 0 will return. So 0 plus 1, 1. Here we'll have 1. 1 plus 1, 2. So here we are having 2. Now this is done. Now come to, we are moving ahead. Index plus 1 is greater than equal to n. Is it? We have already calculated that. Okay. Let me see what we are doing here. This one, two, three. So choices. So we did calculate. So here our choices came as one. If index plus one is greater than equal to n. Is index plus one greater than equal to n? Index, yes, it would be actually. For this we have done. For this we are calculating. So it is one plus one is greater than equal to one. So returning one from the second part as well. So here also we are returning one. Mm. This is meaning that we have reached a valid solution, valid decoding path. If it is okay, okay, let me just write it in a better way. is equal to, then b equal to times 0, an invalid path. So this is fine. Choices equal to this helper plus 4 and plus 1 and less than 9. Hmm. Okay. So okay, yeah. I'll have to memorize the solution. Okay. So I'll wrap up with this. I think we have solved 4 questions. Decode ways